Welcome back, and I have some final comments on correlation. These are more cautions or things to be aware of as we look at scatter plots and those correlation coefficients. Okay, so just a reminder that when we're using the correlation, I should say both variables need to be quantitative. Need to be quantitative. Continuous or discrete, don't much care, but they need to be quantitative. Okay. Also, R does not describe curved relationships. So if you're looking at, if you see anything like an arc in there, that is, you can't talk about the correlation coefficient in that context. So that's why you need to make sure to visualize this. Okay. R is not resistant. Okay, if you were to look at the calculation, it is not a resistant measure. But if you look at the calculation actually takes it looks a lot like the standard deviation in that it takes each observation minus the mean, and so that difference, because we're using the mean isn't resistant, so therefore the correlation coefficient isn't going to be resistant either. Okay. Something to be aware of is that if you are working with averaged data, I'm going to say R of average data is stronger than R of raw data. Okay, so if you can imagine you have some data and maybe it's average rainfall in a year, and then you're comparing it to rainfall in a year, right? We've seen that exercise before in a lab. The correlation coefficient for that average data is going to be stronger than the correlation coefficient for just raw data, mainly because, again, you're already removing some of the effects of those extreme outliers because R is not a resistant measure. So consequently, your R value is going to be greater. Okay. The next thing is that R is not a complete summary. And this goes without saying. When in statistics, you want to have more than one reason or more than one piece of evidence for the decision that you make. Okay, generally speaking. Okay. And then lastly, know that even if there is correlation, that does not imply, so that's why I have an arrow going with a line going through it, does not imply causation. Okay. Just because, and a famous example that I borrow from a sociologist is that if ice cream sales, you can look at ice cream sales in Shark Attacks, and you can see a positive correlation. Well, does that mean Shark Attacks or ice cream sales increase cause more shark attacks? Well, no, because they both take place in summer. So there may be confounding variables that we're not aware of. So don't make the link like, okay, just because there is positive or negative association, that these two things are concretely related to one another. Okay? So those 6 things just be aware of when you're working with scatter plots and correlation. Okay, the last thing that I want to wrap up with is an example. So let's head over to example 3.2 in Excel. And here's the example. It's talking about Huntington's disease. And here in this exercise, you can read it, have fun with it, but I'm going to dive into part A. So it is currently unknown whether, the caudate atrophy might precede or follow any NAA change level or NAA level. So consequently, we don't know explanatory response variables. So it could be one cause or one is influenced by the other or vice versa, but nevertheless, we don't know. So we're just going to display the data and then describe the relationship. Okay, so I'm going to use for right now, for ease, that I'm going to take volume to be the explanatory variable and NAA to be the response variable. So then I'm just going to go to insert, and then there is a quick option here for scatter plot. Okay, and certainly I can, add axis titles and whatnot if I wish. Okay, but nevertheless, I just wanted to describe the relationship. Okay, so this is where I would look at my scatter plot, and I need those three things. So direction, strength, and form. Okay, so I'm going to say there appears to be a positive, strong, linear association. Okay, and so really part A is just asking for the information about the cloud of points, and I did that. Okay, now yes, I can make it pretty and add all the labels. It would be wise of me to also flip the two columns and create a visualization for that. Effectively, all that does is mirror it over an axis, and I'm not so or mirror it over a line, and I'm not so interested in that right now. Okay, but then part B is how strong is the association? So when I say strong, how strong is it? And so give the value of the correlation. So that's where I have to go into Data Analysis Toolpak, go into correlation, select my data, and I'm just going to re-highlight the data. There you go. Output range, yep, I want that. I'm going to put it there. Oops, let's get rid of that stuff. I'm going to put it there, click OK. And so it turns out to be quite strong, 0.81. Okay, so I'm going to say so I'm just going to say strong, positive, linear association, or linear correlation, now that I have the value, with R equal to 0.811725. Okay, so there we go. This one, it didn't particularly ask for the scatter plot, so in terms of grading, I wouldn't be expecting a scatter plot, but it's useful, and I would say I should go back and clean this up, but I'll leave that for you to do.